Hey Ramblers, this video is going to cover section 5.5 in our textbook, and it's going to talk about how to prove that a quadrilateral is a parallelogram. Now in the previous section, or actually in the previous two videos, we've talked about first what the different quadrilaterals are. That quadrilaterals can be broken into several classifications: parallelograms, kites, and trapezoids. Parallelograms can be broken up into rhombuses and rectangles, and finally, the combination of a rhombus and a rectangle, which is a square. So this video is going to talk about how do we prove that a quadrilateral is a parallelogram. Later in the chapter, we'll go a little further to prove that something is a special parallelogram, like a rectangle, rhombus, or a square. So please pay attention. There's going to be 5 different methods. You want to make sure you get all 5 in your notes. I've put the proofs there. You don't need to copy the proofs down, but you should try to understand how the proof works. You'll notice that there's a kind of a common trick in each of the proofs, and that is to draw a diagonal. That will come in helpful with some of the exercises that you'll be doing. Okay, I hope this video helps. If you have questions, bring them to class. There are 5 ways of proving that a quadrilateral is a parallelogram. The first 3 deal with sides. So if we know that both pairs of sides are parallel, then we know the figure's a parallelogram. Well, that's just our definition. So we know that this must be true. And so we're not going to bother to prove this. So let's take a look at the second one. Suppose we knew that both pairs of opposite sides were congruent. Could we then show that the quadrilateral is a parallelogram? Well, the trick is to be able to show that from that given information that both pairs of opposite sides are congruent. The trick is to show that both pairs of opposite sides are parallel, because then we could know that it's a parallelogram by definition. So let's say we started out with that information. Suppose we knew AB was equal to 14.25, and so was CD. Suppose we knew that AD and BC were the same length. Could we show the figure was a parallelogram? Well, let me show you how it would work. And as is most typically the case, we have to draw a diagonal. So we see our given information, and ultimately we want to prove that the figure is a parallelogram. So once we show that AB is congruent to CD, and then we know that AD is congruent to AC. By drawing AC, we know that it's congruent to itself. So triangle ABC is congruent to triangle CDA by side, side, side. Now notice, you have to be careful that you have the proper correspondence of the angles in the right order. So triangle ABC is congruent to triangle CDA, and that sets us up with the next 2 congruencies by CPCTC. Angle BAC up here is congruent to angle DCA down in the lower corner. So by CPCTC, that means that the opposite sides, AB and DC, are parallel because alternate interior angles imply parallel sides. Also, by CPCTC, I know that angle BCA is congruent to angle CAD. And so the other pair of opposite sides, AD and BC, must also be parallel. So, given the information that both pairs of opposite sides were congruent, I was able to show that both pairs of opposite sides were parallel, so therefore the figure is a parallelogram. Okay, let's quickly take a look at the next way of proving that a figure is a parallelogram. If I know one pair of sides are congruent and parallel, can I show that the figure is a parallelogram? Again, we're going to take this given information that one pair of opposite sides is congruent and parallel to try to show that both pairs of opposite sides are parallel, so that we can satisfy our definition that the figure is a parallelogram. If we know one pair of opposite sides are congruent and parallel, we can show that the figure is a parallelogram. So again, we're going to take the given information that one pair of opposite sides is congruent and that they're also parallel to show that the figure is a parallelogram. Let's take a look at the proof. Once again, we're going to draw AC, and since we know that AB is congruent to CD and that AB is parallel to CD from the givens, we'll draw the diagonal, and then we know that triangle B or angle BAC is congruent to DCA because of alternate interior or parallel lines implying alternate interior angles are congruent. Since AC is congruent to itself by the reflexive property, we know that triangle BAC is congruent to DCA by side angle side. That gives us that angle BCA is congruent to angle DAC by CPCTC, which means that the sides AD and BC are congruent by CPCTC, and so the sides are parallel by alternate interior angles implied parallel lines. Therefore, since both pairs of opposite sides were parallel from the given and from what we just proved, we know that all pairs of opposite sides are parallel, so the figure is a parallelogram. All right, let's move on to the last two means of proving that a figure is a parallelogram. Okay, if we know that both pairs of diagonals of a parallelogram bisect each other, we can show that the quadrilateral is a parallelogram. So the first three methods of proving a parallelogram dealt with sides. This one clearly deals with the diagonals. So let's draw the diagonals in. And from the givens, we know that those two parts of the diagonal are congruent to each other. So using vertical angles, we can show that triangle AEB is congruent to CED. So this triangle at the top is congruent to the triangle at the bottom. This means that through CPCTC, since angle BAE is going to be congruent to angle DCE, we know that AB is parallel to CD. Then, through a similar type of proof, we can show that triangle AED on the left side is congruent to triangle BEC on the right side by side angle side. This means that angle DAE is congruent to angle BCE, and so these lines AD and BE are parallel. So once again, we've shown that ABCD is a parallelogram. By taking the given information and then showing that in fact, that allows us to show both pairs of opposite sides parallel. Okay, the last proof I'm going to leave to you. It's going to be much easier to do in Chapter 7, so we'll really present it today as a postulate more than anything else. But it shows us that if we know both pairs of opposite angles are congruent, then we can show that the quadrilateral is a parallelogram. Once again, the proof is much easier with some of the information we'll get in Chapter 7, but suffice it to say, if both pairs of opposite angles are congruent, the figure is a parallelogram. Okay, Ramblers, please get all 5 of these methods in your notes. We use a different one depending on which information we're given. I hope this helps. Thanks for watching.